one-side limits for discontinuous functions. So let me take two examples here to understand the concept of one-side limits and discontinuous functions. Well, one of the good examples which we always take is f of x equals to absolute x over x. So let me explore this first and then we'll take one more example, right? So absolute x over x is our function. Now we know absolute x is basically a piecewise function, so we can always write absolute x as equals to x if x is greater than or equal to 0, and it is equals to negative of x if x is less than 0. That means this function could be actually written as two pieces, right? So we could write this as, I could have written like this also, but let me write two pieces now separately. One is f of x equals to, if x is less than 0, in that case x is going to be minus x, right? So it will be minus x over x. This is when x is less than 0, right? So that is to say that the function is equals to, let me write minus 1 here. But if x is greater than or equal to 0, in that case f of x is equals to plus x over x, which is equals to 1, correct? Now if that is the case, then we can actually draw the function. So let me use this portion to draw the function now. So the function could be, when x is greater than or equal to 0, then the function is 1. That means if this is 1, so this is included here and the function is like this. But if function is less than 0, then the graph of the function will be kind of like this, right? Where these values are plus and minus 1. So this is plus 1 and this is minus 1. So that is our function. Now we have to look into one side limit of this function. What I'm trying to say is we need to find out what is the limit of absolute x over x when x approaches 0 from left side, that means minus 1. And what is the value of limit of absolute x over x when x approaches 0 from right side, that means plus. Now can you answer this question? What is the limit of the function absolute x over x when x approaches 0 from negative side, or the left side, I should say left side? And what is limit of absolute x over x when x approaches 0 from right side? Well, it's clear from here that if you're approaching from the left side, if 0, this is 0, right? You're approaching 0 from the left side, you're approaching a value minus 1. So this is minus 1. However, if you're approaching from right side, if you're approaching 0 from right side, then the limit is plus 1, you see. So the limit exists. One side limit of the function exists, correct? But the important thing here is both the limits are different. Since both the limits are different, and what is the value of the function? What is the value of the function at 0? What is f of 0? So what we see here is that f of 0 is actually equals to 1, right? Second, what we notice is that limit of function absolute x over x when x approaches 0 is how much? Does not exist, since left side and right side limits are different. You see that? So we conclude that the function is not continuous. So this function is not continuous since, very simple, limit does not exist. And also function has a value at 0, which is 1, and limit does not exist. That means limit is not equal to the value of the function. Well, either way. So the function is discontinuous. So what we really conclude here is that a function is discontinuous if the limit does not exist. Very simple. Now let's take another example where the limit may exist, but still the function may be discontinuous. So for that, I think a good example would be, let me write down a function here as f of x equals to, let me write x plus 1 times x minus 1 over x minus 1. Now in this function we know x is not equal to 1, since if I make x as 1, the denominator will be 0, so that will be undefined. So 1 is not in the domain. But what we observe here is that we can always simplify this function, and we can write this as f of x equals to x plus 1, where x is not equal to 1. It's kind of most important to write x not equal to 1. Correct? Now that becomes our function, which is exactly same as the given function. Now let's try to sketch this one. So I'll sketch it on the side here. So we have x plus 1, and we know x is not equal to 1, right? So if I have to sketch it, x plus 1 means this point is 1 and the slope is 1, right? So slope is 1, so kind of like this will be our graph. But x is not equal to 1, that means if this value is 1, then there is a hole here, right? And this point will be 2, correct? If this point is 1. So let me just sketch it. So this function is, that is how the function is going to be. And at 1 we have a hole, right? So it's a rational function where we have one common factor in numerator and denominator. Since that factor cancels out, we have a hole. Now what is the limit of this function? Well, now we'll find limit of the function, which is, I should say, let me write f of x in this case, when x approaches 1 from left side, that means minus 1. What is this limit? And what is the limit of this function f of x when x approaches 1 from right side? Well, let's see. If you are coming closer and closer to 1 from the left side, you are approaching the value 2, right? So the limit is 2. If you are approaching from the right side, you are approaching value 2, right? So this is also equals to 2. So what we see here is that the limit of the function, if I say what is the limit of the function f of x as x approaches 1, so the answer is 2, right? The limit exists. Function is discontinuous, but the limit exists, correct? Now in this case, why the function is discontinuous if the limit exists? That is relevant question, right? The reason is, limit is when we are approaching, limit is not the value of the function at that point. And we know function is not defined at 1. Since the function is not defined at 1, the function cannot be continuous. Do you see that? So there are times when limit may exist, right? The side limits exist. Limit may exist, but still the function could be discontinuous, correct? So in this case, what we see here is that we have two different cases. In one case, one side limits exist, but the limit at that point does not exist. In the other case, one side limits exist and the limit at that point also exists, but still the functions are discontinuous, mainly because the value of the function is not the same as the value of the limit at that point. So that's an important thing to consider. I hope that makes things clear. And this kind of, now whenever we have one side limits, if they exist, that means the type of discontinuity is either a jump discontinuity or a hole, right? So in these two cases we see two types of discontinuities. Either it is a jump discontinuity or it is a hole, correct? Now in the previous video which we saw, one side limits approaching infinity. So that kind of discontinuity was infinite discontinuity, right? So there are basically three types of discontinuities. One which we discussed in the previous video, infinite discontinuity, which was for a vertical asymptote. And here we have two other discontinuities. One is jump discontinuity. So in jump discontinuity, one side limits exist, but the limit at that point does not exist. And when we have a hole, then left and right side limits will exist, and the limit at that point will also exist, right? But still the function is discontinuous. It has a discontinuity which is of the kind of a hole which can be plugged in. So that will be the next example which we'll discuss. I hope things are becoming clearer. So one side limits help us to identify the type of function. If one side limits exist, then the function could have a hole, or could have a jump discontinuity, or could be continuous. If one side limits do not exist, or one side limits are infinite, positive and negative, then there is a possibility of a vertical asymptote, right? So that is what we conclude. I hope that's absolutely clear. Thank you and all the best.